Broadcasting live. It's America's longest running talk show on computers. It's Computer America, bringing you the biggest names in technology with guest interviews, new products, and your emails. Listen live at computeramerica.com on any device around the world. Email the show at live@computeramerica.com or find us on social media. Be sure to check out our website for contests, giveaways, show notes, live video stream, podcasts, and more. You're listening to Computer America.
Hello and welcome everyone into the Computer America Show. We are the nation's longest running nationally syndicated radio talk show on computers and technology turned podcast. Everyone, welcome into the program. I hope that you had a great week. You are ready for a little bit of Ralph Bond. He of course joins us every single Friday to talk about, a number of different stories, anything science and technology trends related, which turns out just about everything. So today we're going to be talking about, mice. We're going to be talking about AI. We're going to be talking about nuclear power, just as one does on a nice casual Friday conversation. And ladies and gentlemen, if you want to find out more, computeramerica.com. That's going to be your best place to go for the show notes, which Ralph puts a lot of effort into. You should definitely go check those out. It has links, it has images, it has videos, sources, references, it has everything that you need for today's program. And of course, so you can find all that there, and some things that we won't even have on the show with the honorable mentions. And with that being said, I think we just bring Ralph on and, kind of head into a weekend where, hopefully everyone out there has a nice relaxed time. You have shaken off, the long week and you are ready for some uplifting news. So once again, Ralph Bond, he is our science and technology trends correspondent, and he joins us here to talk about good things. So Ralph, welcome back onto the program. How you been?
Great. It's great to be back. And friends, if you're looking for positive news, something uplifting, thanks to the world of science and technology, you've come to the right place. And what Ben and I do each Friday is we try to look at where we're headed in artificial intelligence, robotics, medical technology, sustainable energy technology, transportation advances, space research, physics, you name it. All of it's available for us to look at. And what I do is I troll a lot of publications, a lot of outlets looking for interesting stories that fit that category of advancements in science and technology. And we've got 4 stories for you today that we're going to go through. And then we have honorable mentions, which are additional articles you can go check out if you come out to computeramerica.com and get the show notes, which I can't stress enough, especially if you're listening to us as a podcast. Come out, you'll be able to see the images and links to the videos and all that good stuff.
Absolutely. And with that being said, why don't we go ahead and get started with story number 1. And this is something that, I guess I'm just too young, Ralph. Like the idea of a nuclear reactor or like a nuclear power plant opening, it's just something you don't really hear a lot, and just I haven't really heard of in my lifetime. Like, you heard about this golden age of like nuclear power reactors and stuff, like in the 50s, 60s, 70s, which led to great TV shows like Fallout. So, cool for that. But, ever since like 3 Mile Island and Chernobyl, there hasn't been a lot of kind of new nuclear reactor openings because they're big, expensive, they're so much red tape. But story number 1 is different because it's not opening, but it's breaking ground, and that's something you don't hear often, and it's uplifting. Yeah. So Ralph, story number 1.
Yeah, you make some good comments, because actually what I'm seeing a lot in the press, this technology press, is renewed interest in nuclear. And this doesn't relate to this story, but one of the trends that you can watch are small, miniature reactors. That seems to be something that a lot of people are investing money in and looking at as a way.
We've kind of fallen out of love with the giant, Simpsons style, giant nuclear reactor plant.
Right.
That seems to be, going away. But yeah, the smaller ones for sure.
Well, this story comes from constructiondive.com, which is a great outlet if you're a construction technology geek. The headline here is Bechtel breaks ground on a $4 billion Bill Gates-backed nuclear reactor. And I'm going to add on my little addition to this headline. what we're talking about here is the first reactor in the United States that uses sodium to cool the reactor instead of water. That's the kind of interesting twist on this story from a technology point of view. So, Reston, Virginia-based Bechtel recently broke ground in Wyoming on an advanced nuclear reactor that uses sodium instead of water as a coolant, as we just said a moment ago. Bechtel is the engineering, procurement, and construction partner on the job, known as the Natrium Demonstration Project. And this is for Bellevue, Washington-based Terra Power. And Terra Power, which is chaired by Microsoft founder Bill Gates, specializes in nuclear energy technology. Excuse me. The project is part of the U.S. Department of Energy's Advanced Reactor Demonstration Program. So this has obviously some pretty intense linkage in terms of a collaborative research effort here.
Yeah, this is not a fly-by-night, hey, we're going to revolutionize nuclear power. No, they have some very smart people on this.
Yes, indeed. So with a sodium fast reactor, we're going to explain what that means, featuring integrated energy storage and flexible power production, the Natrium Demonstration Project technology offers carbon-free energy at a competitive cost and is ready to integrate seamlessly into electric grids with high levels of renewables. So there's a lot going on in that one paragraph here. So a little injection here that I put in is timeout. Wait a minute. What is a sodium-cooled fast reactor? So a sodium-cooled fast reactor is a type of nuclear reactor that uses molten sodium as a coolant. Keyword here, molten sodium as a coolant. And here's how it works. Sodium-cooled fast reactors utilize liquid sodium metal to carry heat from the reactor core. Sodium allows for high power density with a low coolant volume compared to water-cooled reactors. And we have a link here for the source for that information. And the Associated Press reported this year that the cost to build the Natrium Demonstration Project in Wyoming would be up to $4 billion, as we mentioned earlier. Now, one thing that you have to ask yourself is, well, why use this molten sodium instead of water? I mean, why? Well, Terra Power and Bechtel have characterized the technology as safer than traditional water-cooled designs. That's interesting in there. I'm sure there's more information you can dive into to learn about that. With this system, Bechtel claims that the facility can provide clean baseload operation at 345 megawatts with a capability to flex or boost as high as 500 megawatts. And this can generate enough energy to power an estimated 400,000 homes. Wow. And then I've added in a little something here. I thought, well, who else is doing this sodium cooling reactor stuff? Well, it turns out another sodium cooling reactor is from Kairos Power, that's Kairos Power, a startup that is developing a molten salt cooled reactor that uses a mixture of molten salt for cooling. And I have a link for that as well. So it's not the only game in town, but very, very interesting twist or new kind of phase on nuclear power plants.
Yeah, and really every paper that comes out, trying to figure out where do we go after fossil fuels, because that is kind of where we're heading. Nuclear power is always part of the answer. It's not the whole answer, but is always part of the answer. And I do find it interesting, Ralph, that like you said, this is used in conjunction with high levels of renewables is the words that they use. Very, very interesting, and ties in nicely with last week's article about using molten salt to kind of as a battery, and then now this one uses salt in a nuclear reactor. I'm seeing a trend.
Versatile stuff.
For sure. So very cool. Story number one, and honestly, $4 billion sounds like a lot. I sure as heck don't have $4 billion, but for nuclear power, that is actually very, very cheap. And I was just reading through, reading through the material that you linked to their website. 3 years from pouring the concrete to loading up the thing and generating electricity. Very short as well, where some nuclear reactors take, 20, 30 years to come online. So a lot to like about that one. A lot to like. So that's story number 1. Story number 2, let's go ahead and jump down. And this one is, everyone's going to have to set aside their own biases for this. Because AI and the inherent biases in AI, they exist. I always like to tell people, it's kind of like a kid, you teach a kid, you teach it certain things, and not everything that your kid hears for the first time is 100% absolutely correct. And maybe, the 2 dots that your kid puts together are not always correct. Something is, one thing, if A is B, then B is A, but, it's not always that. So essentially, AI has issues sometimes. It's not foolproof. It's not this magical thing. And, how good your AI is trained or how well it's fed data matters a lot. And story number 2, I think, kind of speaks to this, how, you can improve this process. So story number 2.
Yeah, story number 2. This comes from, I'm in Oregon, outside of Portland, Oregon. And so this one caught my eye big time. This comes from Oregon State University, their Newsroom article. Headline, researchers develop new training technique that aims to make artificial intelligence systems less socially biased. Very, very interesting. You've, like Ben was encapsulating or highlighting the kind of problems that you hear about AI being socially bias and so on. This is an issue, and so this researcher is trying to deal with that. And it's I think a very interesting story. If you're an AI geek, this one's really cool. So Eric Slyman, an Oregon State University doctoral student, and researchers at Adobe, so it's a collaboration, have created a new cost-effective training technique, for artificial intelligence systems that aims to make them less socially biased. They're not saying absolutely not biased, but less socially biased. And the researchers call the novel method fair dedupe, which is an abbreviation for fair deduplication. Okay, this is geeky stuff. Stand by. Deduplication means removing redundant information from the data used to train AI systems, which lowers the high computing costs of training. But there's much more to it than that. Data sets gleaned from the internet often contain biases present in society, the researchers said. When those biases are codified in trained AI models, they can serve to perpetuate unfair ideas and behavior. By understanding how deduplication affects bias prevalence, it's possible to mitigate negative effects. Now, I warn you, this is geeky, such as an AI system automatically serving up only photos of white men if asked to show a picture of a CEO, doctor, etc., when the intended use case is to show diverse representations of people. That's part of their model that they work to try to go after. In addition to occupation, race, and gender, other biases perpetuated during training can include those related to age, geography, and culture. So Eric Slyman, the lead researcher in this, noted, quote, "We named it fair dedupe as a play on words for an earlier cost-effective method they developed called SEM-dedupe." There's a whole other story about that, which we improved upon by incorporating fairness considerations. So he had done some research before, then they added this business about bias, attacking biases, and that's where they came up with this fair dedupe technology. And Slyman recently presented the fair dedupe algorithm in Seattle at the IEEE CVF Conference on Computer Vision and Pattern Recognition. So he's presented this to the world already. And fair dedupe works, and this is where it gets very geeky. Fair dedupe works by thinning the data sets of image captions collected from the web through a process known as pruning. So I think it's very interesting that it's going after data sets of image captions collected from the web and through a process known as pruning. Now, pruning refers to choosing a subset of the data that's representative of the whole data set. And if done in a content-aware manner, pruning allows for informed decisions about which parts of the data to stay and which to toss out or which to go. Oh, there's a lot going on here, folks, and I don't profess to fully grasp it. If you're a geek in this area, you'll have links and you can dive into this man's research. It's fascinating. So Eric Slyman, the researcher in question here, says fair dedupe removes redundant data while incorporating controllable, human-defined dimensions of diversity to mitigate biases. Our research, or our approach, enables AI training that is not only cost-effective and accurate, but also more fair. By addressing biases during data set pruning, we can create AI systems that are more socially just. So there's a lot going on here, Ben. Again, I don't profess to fully grasp it, but it is so interesting that there's this work to try to improve AI. Every minute of every day, people are trying to work on making AI more fair and just and so on.
Yeah, no, it is a real issue with AI that it's
right.
Because AI is very, it can only do essentially what you put in, and it can only mix like two things. Not just two things, but many things. But Ralph, the data that you put in heavily influences anything that it can put out. So if you put in really bad data, one thing you can kind of think of is like the chatbot that I think Microsoft put out on Twitter or something like that. There have been a number of different chatbot instances, and Ralph, people spoke very inappropriately to it. And it quickly became like a white supremacist, kind of Nazi sympathizer kind of chatbot. That's a good example of, depending on what kind of data you put into these systems, your outputs will be very, will be very obvious. So, Ralph, not saying that this is to combat, kind of white supremacy ideology. It's more like, if you have better data, you can get a better result. And this is, kind of looking at more of the social side of it, instead of, because Ralph, it's pretty easy to say 2 + 2 = 5. That's pretty easy to prune, and that data probably won't make it in there to begin with. But it's about getting good data for things that are not as obvious as 2 + 2 = 5. You're looking at biases. It's a big task, and I'm surprised that you found this in a local publication, because this is an issue that every single company out there who's making one of these things is working on. So best of luck to them. But man, that's going to be a big issue, and one that won't be fixed overnight. So there you go.
Yeah, and one last comment. It's fascinating to me that this is a collaboration between this doctoral student at the university, or Oregon State University rather, and Adobe. Yeah. Interesting collaborative there. I thought that's also kind of a fun twist.
Adobe is one of the leaders in AI for sure. And obviously with Adobe, they do a lot with visual things, pictures and generating images and stuff like that. I can imagine that ethics is, plays a huge role in what Adobe does. So, good luck to them, and, good luck to that doctoral, student. So with that being said, story number 2, story number 3. Yes. And this one is, Ralph, you often mention, hats off to all of the mice and test animals and other things like that have to, unfortunately, advance our understanding of science and, have to meet an untimely end. But I will say, finally, not just a bad outcome for mice, but we're supercharging them and we are improving their lives. So, hey, a win for the mice. Story number 3.
It is. Yes, and the next 2 stories, 3 and 4, usually we use our last story each week is a medical technology and science related. In this case, we're going to do 2 in a row. So story number 3 comes from sciencealert.com, great outlet. Headline, changing a single gene gave mice supercharged hearing. So in this case, the mice didn't have to give up their lives. They actually got their lives improved. To your point, Ben, it's kind of fun. All right, so here's the story. In an effort to better understand hearing loss, University of Michigan scientists have created mice with supercharged listening abilities. The researchers achieved this by dialing up the test animal's expression of a nerve growth gene called neurotrophin 3. So I had to find out a little bit more about this. So side note, neurotrophin 3 is a protein encoded by the NTF3 gene. It belongs to the nerve growth factor family of neurotrophins. Oh, this is geeky stuff, folks. Neurotrophins are a family of proteins that play essential roles in survival, development, and function of neurons. So again, folks, this is geeky, but really cool. But going back to the story, the Michigan Research Lab previously showed that increasing neurotrophin 3 expression can improve hearing in middle-aged mice. It can also help recover some hearing in mice with damaged inner ears. So we're talking about gene therapy here, folks. This is what's really going on.
Mm-hmm.
Now, it does so, by increasing the number of connections called synapses between hair cells in the ear's cochlea and the brain. The hair cells react to sound vibrations and turn them into signals, which the synapses then convey to the brain's neurons for interpretation. That's a little bit of hearing 101. And the University of Michigan neurobiologist, Gabriel Corfes, noted, quote, "We knew that providing neurotrophin 3 to the inner ear in young mice increased the number of synapses between the inner hair cells and auditory neurons, but we did not know what having more synapses would do to hearing. We were surprised to find that when we increased the number of synapses, the brain was able to process the extra auditory information, and those subjects performed better than control mice in the behavioral test."
Different.
Pretty cool stuff. Yeah, very cool. Goes on to say here, boosting neurotrophin 3 expression in mice caused an increase in the density of their synapses, in turn improving their ability to process and therefore distinguish between sounds of different qualities, basically improve their hearing. Increasing neurotrophin 3 expression has the potential to improve hearing in humans too, the researchers believe. So again, folks, a good example of trends. This is early research, of course, with mice. They're encouraged and they're saying to the world, this could possibly help us, we humans. And here's a quote here from the researcher Corfas. It says, quote, "Some neurodegenerative disorders also start with a loss of synapses in the brain. Therefore, the lessons from the studies in the inner ear could help in finding new therapies for some of these devastating diseases." Wow. And in the show notes, I have a link to the research paper, the extraordinarily geeky research paper, which is in PLOS Biology Outlet. So you can go out and geek away on this if you're a medical person.
Yeah, I am such a layman that I'm sure a lot of that went over my head. But what I do, but what I do understand from that is, this kind of research. I guess like a lot of it, Ralph, is like, I'm thinking like cochlear implants and stuff like that, where people who have like damaged the little hairs inside their ears and whatnot, it sends that signal to the brain. Right. This just makes the brain more better. Yes, I can say that. No, it actually increases the neurons in the brain. So this is solving a different part of the equation than just like an implant. So, hey, it's and I know that gene editing, like every so often I'll write an article that's explaining basic concepts and try to help people, just have something I can point to. Ralph, I feel like, again, I'm not a science person whatsoever, but I think gene therapy has come up enough in so much, like CRISPR is the technology that came out, about a decade ago and is making huge moves. You had an article the other day about it was a little baby that was able to hear, I think, due to gene therapy.
Yes.
Yep. And little questions like, Ralph, like, how long do these things last? And the answer is ideally a lifetime. Like, you go through the therapy and a couple of treatments later, it alters your DNA. It alters your cells, and it lasts a lifetime. There's no other like medication that you need to keep doing to, kind of stay on it. It's such a cool technology, but even myself, I have a hard time kind of keeping it straight. So I feel like that's something that I need to work on, is maybe an article that we can point people to and be like, hey, if you're curious about this and how this works, here's
there
how
goes my dog. Sorry about that.
No. We can't even hear it. Can't even hear it. You're
hey,
good
bandit.
to go. So with that being said, story number 3, story number 4, before things get too crazy over there with Ralph. Story number 4, this is a robot that helps people with mild cognitive impairment. So the classic joke is, according to my wife, I should sit up and listen to this. So let's talk about CARMEN, Ralph.
Yes, in fact, relative to my wife, she would probably like me to have this gene therapy to improve my hearing and then deal with my mild cognitive impairment. So you're right. So this comes from University of California, San Diego, their website news outlet, which is really great. And we have a link in the show notes, of course. Headline, Meet CARMEN, a robot that helps people with mild cognitive impairment. And I just want to preface this by saying robot, it can mean a lot of different things. I think for most of us, including me, when someone says robot, I think of like a humanoid robot or one of those dog robots from Boston Dynamics, that kind of thing. That's a robot to me, something that moves around and does things, or a robot in an industrial situation, building products or moving packages around. This is a different kind of robot. Okay, I want to say that from the outset. So let's get into the story.
Well, and I also want to say kudos to CARMEN, the robot from the University of San Diego. So CARMEN in San Diego. There you go.
Yeah, this is very cool. And the pictures in the show notes kind of show what I'm talking about. It's not a move around the room.
Well, I'm just saying the CARMEN San Diego, the old computer game. I don't know if you remember from the 90s.
So, yes.
There you go.
That's funny. So mild cognitive impairment is an in-between stage between typical aging and dementia. It affects various areas of cognitive functioning, including memory, attention, and executive functioning. About 20% of individuals over 65 have this condition, with up to 15% transitioning to dementia each year. Tragic, just tragic. Existing pharmacological treatments have not been able to slow or prevent this evolution, but behavioral treatments can help. So behavioral therapy. Researchers at the University of California, San Diego programmed their CARMEN small tabletop robot, again, take that with quote marks, to deliver a series of simple cognitive training exercises. And CARMEN, by the way, of course, is an acronym. It stands for Cognitively Assistive Robot for Motivation and Neuro Rehabilitation. So that's what the acronym stands for. And my comment, I want to insert something here. Again, as I said before, it's not a robot that moves around, but instead a screen-based device that interacts and prompts patients with screen messages, etc. Now, going back into the article, to support cognitive training exercises, the robot can teach participants to create routine places to leave important objects, such as keys, or learn note-taking strategies to remember important things. And CARMEN, the robot, does this through interactive games and activities. Pretty clever. To the best, and here's the key thing, to the best of the researchers' knowledge, CARMEN is also the only robot that teaches compensatory cognitive strategies to help improve memory and executive function. So this is a breakthrough, a first in this field. And the research team designed CARMEN with a clear set of criteria in mind. It is important that people can use the robot independently without clinician or research supervision. That's the point. For this reason, CARMEN had to be plug and play without many moving parts that require maintenance. The robot also has to be able to function with limited access to the internet, internet, as many people do not have access to reliable connectivity. And CARMEN needs to be able to function over a long period of time. And the robot also has to be able to communicate clearly with users, express compassion and empathy for a person's situation, and provide breaks after challenging tasks to sustain engagement. Now, if you're looking at the picture in the show notes, it's a small little unit, but there's a lot going on in this little unit.
Yeah.
It's pretty great, pretty cool. And researchers also plan to give CARMEN the ability to have conversations with users with an emphasis on preserving privacy when these conversations happen. And the University of California, San Diego team says the next steps include deploying the robot in larger numbers of homes. So again, early twinkle of the eye research here, first level of this. Now they're going to go out and deploy this in large number of home situations to see how viable this is. But again, it's a great example of trying to figure out how to do rehabilitation remotely so you don't have to have an expensive and difficult to deploy expert sitting next to you trying to do training face to face. This is a remote, self-contained, self-training device, which I think is just wonderful.
And I get the idea of a robot, and if you're watching the video portion there, you can kind of see where, you know, it's not just like a little screen with like blinking eyes. Like the head actually moves, it kind of tilts, it, you know, gives it a bit more, you know, a bit more emotiveness than just you know, than just a tablet. But Ralph, I'm kind of curious, like why they decided to do that instead of making it much more, I guess, kind of accessible by making it completely on a tablet, for instance, and having like, you know, the eyes built into the screen of you know, kind of the brain training and brain games.
Yeah, good question.
I don't know why they decided to do that, but I'm sure there's a reason, and more so to the idea of AI, you know, that was story number 2, but AI in general, you can imagine that if someone needs that constant daily training, intensive training, having the ability to not just like talk at a person who may have cognitive difficulties, but for AI to be able to come in and say, you know, to keep that conversation, carry it forward, let the person know when they forget something, and, you know, kind of train them as well. There's a lot of promise in AI as well for that kind of research and that kind of rehabilitation as well, because the AI won't forget. So there's cool things there. So Ralph, very, very nice. Story number 4, CARMEN San Diego. Good job. I actually like that one a lot, and great medical story to kind of head out on. But for those out there who are looking at the show notes and being like, but wait, Ben, you're only on page, what are we on, page like 8 of 12? Yeah, there's still 50% more to go. Well, 50% additional to go. Ralph, what are these honorable mentions?
Yes, honorable mentions are stories, as you often say, Ben, that they're honorable mentions not because they're not as good and as exciting as the other stories we just covered, but because we just don't have time. But I did want to share these. Here's one from the New York Times. This one's kind of creepy if you're looking at the video.
It's
here.
creepy.
It's very interesting. Robots get a fleshy face and a smile in new research from Japan, by the way. Wow, this is just more about robotics and making these humanoid robotics more human-like, and it's creepy and fascinating all at the same time. So check that one out.
Your note of being Hannibal Lecter-esque is very on point here.
Yes. The next one is tiny algae-made robots. Again, think of your definition of robots has to be expanded. Tiny algae-made robots treat inflammatory bowel disease without drugs. This comes from Interesting Engineering. Again, there's so much research in swallowable robots, if you will, this time made from algae, which is kind of an interesting twist. So check out that article. Next one, new bionic leg can be controlled by the wearer's brain. And this comes from futurism.com, a very encouraging, very exciting development in prosthetics. And this also comes from research from MIT. Hooray for them. Next one. This one's our last honorable mention, and this I want to qualify right up front. There's some dispute in the comments from readers and so forth about the research that was done to back this up. Is this really viable or not? And so on and so forth. So a little warning there. But the headline is Tech Company Unveils Tiny Spheres That Outperform Solar Panels Using Both Sun and Artificial Light. And the company says they could hit 60 times the current capacity. This comes from the cool down. Again, I stress there's some controversy about whether this is really legit or not. But I did think, regardless, I thought the idea of if you will, a solar panel that's not a flat thing, but a kind of a faceted, looks like a faceted diamond spherical shape. I thought that was kind of interesting. So check that one out as well.
Kind of like the Epcot globe. You know, it has all the different facets to it. So and hey, you know, the controversy is of course always going to happen with big claims like 60% increase. But hey, you know, that's where research and that's where trends, you know, kind of comes into play. What's going to happen over time. So, Ralph, thank you so much for coming on and sharing these stories with us. Everyone out there, thank you for taking your time and listening to us and you know, go through these stories. We hope that you gave you something to talk about this weekend, you know, something to uplift you going into the weekend. And Ralph, until next time, thank you so much. Listeners out there, thank you. We'll catch you here, computeramerica.com. Everyone have a good one. Bye, everyone.